So once we've set up the null and alternative hypothesis, what do? Well, no matter which hypothesis represents the claim, you always begin the hypothesis test assuming that the equality condition in the null hypothesis is true. So we're basically taking the null hypothesis and assuming it's true. And then we're going to make a conclusion based on that. So there are only two decisions that you can make. All right. You can only reject the null hypothesis or fail to reject the null hypothesis. Basically, you're going to say that the data that you have causes you to reject the null hypothesis, or the data you have does not allow you to reject the null hypothesis, so you have to fail to reject. So you either reject the null hypothesis or you fail to reject the null hypothesis. That's it. All right. Now, one thing we should entertain is, well, we're not going to be perfect here. We're basing decisions on a sample, and we could get a very strange sample. So there is a possibility that we make the wrong decision. We reject the null hypothesis when in truth we shouldn't have, or we fail to reject the null hypothesis when in truth we should have in reality, which we're not really going to know, but we have to characterize what could go wrong in those situations. So there are two types of errors, okay? Basically describing the two situations that I was talking about. All right. Overall, we have four different situations. All right. You're only allowed as your decision to make these two decisions. You either do not reject the null hypothesis or you reject the null hypothesis. Okay? So those are the decisions you make. Now there's some actual truth, which we don't know, but there is actual truth. So the actual truth is that the null hypothesis was true or the null hypothesis was false. We made a determination based on our sample, but we might not have made the right decision. So let's see how this matches up. Let's say we decided that we do not reject H0. We had to fail to reject H0. Well, if we didn't reject it and it was true, then we made the right decision. We didn't reject it and it was true, so good. Now, if we didn't reject it, but we should have because it was false, then we made a type 2 error. Whereas if we rejected it and it was true, that's a type 1 error. If we reject it and it was false, we made the right decision. So that's the correct decision. So let's go a little deeper. So a type 1 error occurs if the null hypothesis is rejected when it's true. All right. You rejected it, but it was actually true. And that's a type of error. You made the wrong decision because you rejected it, but you shouldn't have because it was true. That's a type 1 error. This is also known as a false positive in some testing situations. Okay, a lot of times when you get tested for a disease and you get a positive test result, but it shouldn't have been, so it's a false positive. Okay, so the other possibility of making an error is the type 2 error, where you should have rejected it, but you didn't. You should have rejected H0 or H0, and you didn't, but it was false, and that's why you should have rejected it, but that's your type 2 error. All right, and this is a false negative. All right. Now, these can have very different connotations in real life. So let's look at an example here. Let's say we were testing beef for salmonella. All right, and the USDA limit for salmonella contamination for ground beef is 7.5%. A meat inspector reports that the ground beef produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether the meat inspector's claim is true. When will a type 1 or type 2 error occur? Which error is more serious? Okay, so first we have to set up the hypothesis so we know what's the null and what's the alternative. All right, so let's go back into it. All right, P is going to be the proportion of ground beef that is contaminated. The inspector reports that the ground beef produced by a company exceeds the USDA limit. So that inspector is saying that P is greater than the 7.5%, or in other words, greater than 0.075. All right, that's what the inspector said, that the ground beef exceeds the 7.5%, exceeds, greater than. Now, does this have an equality in it? No. So it goes in the alternative. P greater than 0.075. All right. What is the other part of it? Well, if it's not greater than that, it's P less than or equal to 0.075. And the claim was that it was greater than. Okay, so there we have our situation. There we have our hypothesis test. Okay, so what would happen? Well, now we can see basically at on a graph here the two regions. The null hypothesis, which includes the equals as P less than or equal to 0.075, and the alternative, in this case the claim, that P is greater than 0.075. All right, so let's see what would happen. All right. A type 1 error is rejecting H0, H0 when it's true. Okay, so this is H0 saying that the proportion is less than or equal to 0.075. So what would happen would be is your data would be telling you reject that, except the proportion is actually less than or equal to 0.075. All right, so it's less than or equal to 0.075, but we rejected it because of what our data said. We made a mistake. We made an error. That's a type 1 error in that case. The other situation would be, remember, we're only talking about either rejecting H0 or failing to reject it. So let's say we fail to reject it based on our data, but it's actually false and we should have. We made an error. So this would be the case where it's false, meaning the proportion is actually greater than 0.075, but we didn't realize that. So the actual proportion of contaminated ground beef is greater than 0.075, but we didn't reject the statement, the hypothesis that it was less than or equal to. So we made an error. In this case, the type 1 error, you would have, let's go back, the actual proportion of contaminated ground beef is less than it. So according to the according to the, the USDA, it's safe, but you rejected it saying it's not safe. Well, you might create a health scare and hurt the sales of ground beef, which actually met the limits. It was okay, but just said it was no good. In the other case, you're actually allowing the ground beef that's contaminated to be sold and you shouldn't have, because you were supposed to identify that it was over the limit. So in this case, that's not always going to be true, but in this case, the type 2 error was more severe because you put people in jeopardy of sickness when it should have been avoided. So with this in mind, that there are going to be errors, we often set some level of significance that tries to quantify, our chances of making that error. So your maximum allowable probability of making a type 1 error. So we're going to focus on the type 1 error and phrase it in terms of that. This will be denoted by alpha, which is the lowercase Greek letter, alpha. So by setting that level of significance at a small value, you're saying you want the probability of rejecting a true null hypothesis to be small. So we often use these values, 0.1, 0.05, and 0.01, which we talk about as 10% level of significance, 5%, or 1%. Now, you could phrase it in the other way with the type 2 error. In that case, that probability we call beta. But we're going to, for our purposes here, phrase everything in terms of alpha, talking about the type 1 error.